so as we're talking about analytics, the main issue is that it's a tool which is actually going to facilitate in decision making problems. So if there is a decision which has to be taken, it could be a business decision, it could be a scientific decision, it could be a medical decision which is relating to a patient. So what we want to do is that we want to actually look at the data which we have collected from past experience, and then use the data to actually formulate a model, and that model should actually be able to give us those outcomes that we are looking ahead to. So we want to actually come up with a situation or where we are able to use the past data that we have, and based on that create a model, and that model should be able to give us either a understanding about the phenomenon, or should be able to prescribe a solution for us, or should actually help us in also doing cognitive decision making process. We'll cover all this as we go along. So now if you look at this small caption here, it says, "In God we trust and all others bring data." Now this is an interesting and a controversial statement as well, which says that, well, in almost all situations, it could be any sphere of life and as well and work, that if we have to take a decision, then we are better off if we have data supporting that decision, rather than hoping and believing that whatever decision we are taking is right. So we want to have past data, analyze the data, come up with a model out of it, and that model should actually help and facilitate us in improving the decisions that we are going to take. Okay, so another interesting quotation from Gary Loveman, who also works in the sphere of analytics, artificial intelligence. He says, "Do we think this is true, or do we know it is true?" Right. So that is the way of looking at it. That we might think that a lot of things are true, but does data say the same thing for us? So we want to actually have our decision making augmented based on the inputs and the data that we have with us from past experiences or past inputs that we had in a similar situation or related situation. And that's what we would be preferring to do. So now if I look at this chart here, so this is talking about a very interesting concept here, that the degree of intelligence is shown on the x-axis, and the degree of competitive advantage, you want to call it in business scenario, or if you want to talk about the advantage that we're going to get as an individual, maybe in terms of or even you can call it competitive advantage for an individual as well, if we actually apply that technique or that mechanism. Right? So let us look at how how the degree of intelligence increases along the x-axis, and correspondingly how do we get better advantage, or how are we ahead of others who are trying to do the same thing, and we could actually perform better than them. Right? So let's have a look at that situation. Right? So if I look at the diagram here, which you can see on your screens. So if you're at the lowest most point, that is 0, 0, if you talk about, or maybe slightly ahead of 0, so that's at the so I'm talking about this point here. So sorry. So I'm talking about this point here. So, or this construct here. So if you, the first thing that we can do is that, suppose we have a lot of data with us, and we have accumulated a lot of transactions based on prior activities that we have done, right? So it could, in the medical space, it could be the patients that you have treated prior to this. If you're thinking about maybe an Amazon or a Flipkart, then it is about the transaction that a person might have made, the book that he might have purchased, or the item that he or she might have purchased. That could be the transaction data that we have. Now, if you want to figure out that what happened, so then we are just generating some standard reports out of that database. So we can query the database, and the database can give us some summarized outcomes in terms of how many people did that particular activity, or how many people had that particular disease or had that particular symptom. So we can actually summarize it. So that is actually standard report, where we are just summarizing the existing data that we have based on one or two parameters that are most important or of consequence to us. The second one is ad hoc reports, right? So So the first one is if you want an answer like what happened. In the second case, suppose how many, how often, and where, right? So suppose we wanted to find out maybe in this COVID situation that where are we getting most number of cases, why is a particular region becoming a hotspot, and then are we able to contain it or are we not able to contain it, and things like that. So then we might be requiring ad hoc reports. So which would be again based on based on the data that we have collated. So we have done maybe RT-PCR test, and that data is in our database, and then we are trying to find out how many, how often, and where that is happening. Now, if you want to even drill down more, and if you want to figure out that, well, if you find out a particular part of the city which is getting impacted by say COVID or is becoming a hotspot, then why is it happening? Are we having too many travelers coming into that region from other parts of the country or from other parts of the globe, etc.? So we can actually drill down and figure out what is that which is happening, or is there anything specific that they're doing that maybe they're not wearing a mask or they're not actually adhering to the COVID protocols, etc. So that could be a drill down thing. Now, post that, we might also want to figure out what actions are required, right? So if we want to actually figure that out, that would also require actually the current data and also the proposed solutions that we have. We need to combine them together, and based on that, we can actually figure out what actions can actually help us solve the problem. So till this point when we are here, so if I just draw 45, this is almost a 45-degree line, as you can see, and all of us can understand. So till this point, when we are till this point here, not too much of intelligence is getting, or we can say we have got moderate amount of intelligence. So say for example, I call this 0, and if I call it 100, so maybe we have reached around 40, 45% or 50% intelligence we have gained here till this point. So this is from the regular data that we have and regular reports that we're generating or querying based on our past experiences that we had, right? So that is what we're doing here. Now, if we want to actually deeper into that data set that we have, then we have to actually start getting into things like statistical analysis, right? So as all of us know that we have got lots of tools in statistics which can actually summarize data, which can actually figure out, do hypothesis testing for us, which can do ANOVA testing and things like that, which can actually help us in understanding why this is happening, right? So if we find out a particular event happening, so maybe like for example, again, if we go back to the COVID case, that comorbidity is leading to more deaths. So why is it happening? Can we have statistical evidence for it? And can we actually then find out a mechanism to minimize or reduce that? So that is where the statistical analysis comes into play. Then after that comes this forecasting, right? So now if I have done a statistical analysis, I have been able to figure out why a particular event is happening. So we have been able to answer that question, why. So we are slightly better off in explaining that phenomenon or getting an understanding that why that phenomenon is happening. Right now, if I want to project it, like again, if I just go to the COVID example that we have been having the charts in terms of time. So here we had time, and here we had number of cases, and we were all seeing this being developed and being shown to us, like when was the peak and when we're going to come down and when we had the second peak and so on and so forth. So we are actually trying to forecast based on the understanding that we have of the data, and then trying to fit a curve onto it or find a distribution, and from there trying to forecast that when would the peak happen, when would the next when the deep is going to happen, and are we going to have another second peak maybe, and around what time is that going to happen, and so on and so forth, right? So this is about forecasting, and I think all of us understand well, right? So this is a time series sort of a situation where the variables we are looking at over time, right? So in this case, the variable that we are looking was number of cases of infected patients actually, which we are looking over time. Then we come to a thing called your predictive modeling, right? So what will happen next? So yes, forecasting is one of that. Forecasting is on time, and prediction can be not only on time, but you could also want to predict something along with it, right? So say, for example, we might want to predict the GDP of a country. Maybe if I just talk about it in the economic context, then can I predict the GDP of the country, or can I predict the stock price of a particular event? Similarly, I can also maybe you can predict that when are we predict whether we are going to be, or when or how soon are we going to get rid of COVID. So can I predict that? So that can be also another interesting mathematical tool which can be used to do it, right? Then finally, what we are trying to do is about optimization. What's the best that can happen? So if I know we have all got limited resources with us. Using this limited resources, can I now plan and come up with a very effective schedule or a plan which will actually will let me know that how I should actually deal with the situation, like maybe a COVID or maybe other diseases, etc., which need to be contained, and we don't have too much of resources at our disposal. So how can we actually contain it? So can I have a very optimal model where all my resources are actually being used optimally? And so my doctors are limited, my nurses are limited, my beds are limited, my ventilators are limited. So how do I actually come up with an optimal model which can be the best case situation that I can have? So this will give me the maximum amount of intelligence is in this model, and I can be better off compared to other states, maybe compared to other countries, maybe, and uh, everybody, our society at large, would be in a better off situation. So this is how we can look at analytics. So first and foremost, we are looking at the regular data, the regular reports, etc., that we generate. And this part is slightly more involved, where we are trying to actually slightly deeper, and trying to find out the causality, why it is happening. Then we're trying to forecast what is going to happen. Then we're trying to predict, if possible, what is going to happen, and then we're trying to optimize it. So, so that is what we're trying to. So, as they call it, descriptive analytics, predictive analytics, prescriptive analytics, and finally, we have got cognitive analytics. So cognitive analytics is the best case scenario where we can think about autonomous machines becoming autonomous, like we have driverless cars, etc., where they can start behaving or behaving like a human being and try to start taking decisions on their own.